S3 simple storage service. Now what is this all about? Today we'll see S3 introduction, S3 concepts, tools and APIs, S3 in details. So starting with the S3, Amazon S3 is a storage for the internet. It's an internet-based storage. It is designed to make a web-scale computing easier for developers. Now, if I want to give you a little easy analogy, you know what is the FTP site, right? So FTP is a protocol, I know. So I'm not talking about that. But there are normally FTP sites where you can upload some content over there. So you can upload files over there. This is a little, not 100%, I would say 50% analogy. The best meeting to Amazon S3 is, have you used the Google Drive? This is the same case. Amazon S3 is almost same as the Google Drive. It's a storage for the internet. So anything, any content you want to store over the internet and want to share with your friends or want to share for your future use, you can use Amazon S3. Amazon S3 is a very simple web service which can be used to store and retrieve any amount of data at any time from anywhere over the web. It is scalable. You can store any amount of data, like starting from 1 bytes to into petabytes you can go. At the same time, if you are using any tools like what someone was mentioning about the Eclipse and all that, you can also make your application to upload or download the objects over there. It's a scalable, reliable, fast and inexpensive. Much inexpensive because it's a pay-as-you-go model. It's a very easy to use, and when I show you the demo you would be understanding why it is so easy to use. Now Amazon S3. So we already studied about Amazon EBS is one of the storage service. Now we came across Amazon S3. Now what is the purpose of Amazon S3 and why not EBS? So as I said, Amazon S3 is storage for the internet. So where you want to store anything, any files. Again, see, remember on this slide I am using a word called file. After one slide I'll not use this word called file, I'll use some other term for the S3. But when you want to use any files or any objects, rather that's the right word, but any files you can upload over the Amazon S3. So you have a doc file, PDF file, image file, video file, and you want to share with your friends, CSS, HTML. The most important, any static content you want to share over the internet or store over the internet, Amazon S3 is for that purpose. Now when you try to map it with the EBS, so EBS and Amazon S3, Amazon S3 is an object store. So they do not call anything as a file, they call it everything as an object. So whatever you upload over Amazon S3 is called an object. Whether you upload a PDF, you upload a doc, you upload a video, you upload an image, you upload a CSS, HTML, JavaScript, everything is called an object. Any static content whichever is uploaded on Amazon S3 is called an object. It is not called a file. And why? I'll come in a next slide. So it's an object storage. So basically it's for the static content storage, while EBS is like a file system. So EBS is like your hard disk, where you will have an operating system and a file system. You can store the files, database, static content could be there. It can be used, it can attach to a processing unit and then do the processing part also, like it connects to the EC2 instance. Performance wise, EBS is definitely much faster because it's over the remote chases or it's over the internal data center, while Amazon S3 is still a much fast, but not as fast as EBS, but since it's over the internet. Redundancy is an important aspect. See what happens in EBS, if you remember, it's a zone specific EBS. So in the EBS, whenever you make an EBS volume, the data is replicated for the backup within that data center only, means within that zone only. If you remember that cluster and nodes concept I explained last week, it will be replicated across the same availability zone only. While in S3, the data is replicated across the region into multiple data centers. So if you upload something, Amazon S3, the most important is never a region specific thing. Is never a zone specific thing, is always a region specific thing. There is no concept like zone within Amazon S3. It's only region. So whenever you upload an object, it is always going to some region. And now within that region, that object would be replicated to multiple zones, such a way it can survive at least 2 observability zone failures. So even if the 2 zones are down, it can still serve your request. So that's why it's a highly durable, highly available system. Security wise, EBS, it's only you can access from the EC2, so you cannot even access from the internet directly, while S3 is accessed from the internet, but you can always set certain kind of a keys over there for your security. There is a concept called access policy which you can use over there. What is the typical use for any static content storage and sharing? It is used, so write once, read many, while EBS is like your disk drive. So it's very important to understand the difference between EBS and S3. S3 is for static content only, while EBS is a file system. So anything you want to, then you can always ask, what is the use of S3? See, you have a lot of images file as part of your web application. Now, if you put that image files inside your web server, it would take a time for the web server to process and deliver to you. Instead, if you store those objects or store those files into S3 and just give the URL of that S3 in your web page, it would be much faster to deliver over there. So this way, Amazon S3 for storing and sharing any content over there, over the internet. Now, Amazon, the why S3 is one of the key aspect also, because Amazon started its service with, or rather Amazon started its cloud offering with Amazon S3 only. The first thing to come out from Amazon as a part of Amazon Web Service was Amazon S3. They started in around Q4 2006, and you can see in almost 7 years, this is a little old data, they have not published the latest one, but what I believe, by Q2 2013, they have more than 2 trillion, yes, I'm talking 2 trillion objects inside S3. And what I believe is now by 2014, it has already crossed 3 trillion objects. So more than 3 trillion objects inside Amazon S3. So that's a great thing. So you can believe how many things are stored over there. And that's the best example, pay as you go, scalable on-demand service. Now let's go and understand the S3 concepts. So S3 has a concept called bucket and object. Now anything what you upload over S3 is called an object. Now why do we call it an object and why don't we call it a file? The reason is, a file, as we know, has a certain data or metadata rather, that what is the file size, what is the date it was created, date it was modified. There are a few metadata for that. Here it is having a numerous number of metadata attached to that file, and that is the reason it is called objects. So S3 is a object-based storage system. And if you Google out again or read on the Wikipedia, what is the object-based storage system? They clearly mention something which is an object is having a multiple metadata. Metadata is like what? A key value thing. A key means what is the name of the object, and then value would be this is the name of the object. Then what is the size? The key is a size, value would be size. Key is a date, value would be date. Key is a security or the access control list. What is the access control list? Key is the headers, then it will be having the headers. So there would be a number of metadata attached to this file. So that is the reason any file we upload to Amazon S3 is called an object. So if somebody asks you anything about Amazon S3, it's an object-based storage system. Anything what you upload over there, over the internet, it's an object. Now, this object cannot lie independently. It has to be part of a bucket only. Now, bucket is synonymous to a folder, but I won't use the word folder because folder is little different in terms of Amazon S3. We will talk about the bucket only. So, bucket is a container for an object. So, it can have up to you can have 100 buckets for each Amazon account, and within each bucket you can have unlimited number of objects. Apart from that, what would be the size of the object? Each object size can be starting from 1 terabyte to be maximum to be, sorry, 1 byte, starting from 1 byte, it can go up to 5 terabytes of the size. Sorry, 5 GB. I'm sorry. I guess 5 GB was the size. Yeah, sorry, 5 terabytes. I'm extremely sorry for that. The maximum is a 5 terabytes. You can go for that. So from 1 bytes to it can go up to 5 terabytes of the size, each object. Now, a key. What is a key here? Each object is identified with a unique key, like a name, then what would be the value of that? So it's a key value pair kind of a scenario, and through which the object is identified. Each object would have some access control list also that would help you to identify that this object is shareable over the internet or not. We will see in detail about bucket, object, key and access control list when we do the demo part. Now, in S3, you can store an object up to 5 terabytes of size. So one object can be of maximum 5 terabytes. You can store unlimited number of objects, each of 5 terabytes, that is fine. You can entirely read or write the object. Also, each object would have a unique developer assigned key, that is like a name. So key would be name and it would have some value over there. All objects are always stored inside a bucket. No object can be an independent. And each object, the most important aspect is each object would have a unique URL. So using that URL, it would always be accessible over the internet. So since you access the S3 objects on the internet, it will always have a unique URL to access the objects. It is having intrinsic redundancy. We talk about that. It's replicated across the data center within a region. The owner would have a full control access on the objects. It can perform whatever, as well as it can share the controls also. It follows a eventual consistency data model, and that's a very curious case. I'll explain that in detail in the coming slides. One more aspect which is very important is that it supports versioning. So somebody just asked me, write once, read many times. So in the same case, you may like that, okay, if I upload, generally whenever you upload an object, it overwrites an existing object. Now, if you want to store that, when I want to keep the backup of the original object, what you need to do is you need to enable a versioning. You can always enable a versioning. Once you enable the versioning, it will delete the original one. It will not delete the original one, and it will keep on creating new version every time you upload a object. Only trick here is this versioning is supported from the APIs and SDK only. Means if you want to get the older version of the objects, you can get only from the APIs and SDK. Currently, that is not supported from the Amazon S3 console. So if you enable the versioning and you upload a new version, it would definitely keep the original version as is and create a new version on top of that. Only trivial part would be if you delete the original version or the new object which you uploaded, the version will still be lying there and you cannot see because it's the older versions are never accessible from Amazon Management Console. In that case, you have to write some SDK program to access those versions objects. So use this versioning very carefully. Unless you have some production real requirement, you should not do it just for the R&D purpose, else you will not be able to delete those objects. Now, how do you use an Amazon S3? So normally you are signed up for the Amazon S3. You can create a bucket. Once you create a bucket, you can add an object inside that. You can view the object, share the object, move the object from one to another region. So those are the various options available with Amazon S3. So an object is comprised of a file and optionally any metadata that describes the file. So that is a very important aspect, that it will have a object with a file and as well as a metadata it will have. To store an object in Amazon S3, you can upload the file you want to store to a bucket. So you upload a file and that becomes a metadata because, object, because you can also assign a multiple metadata to that. Buckets are containers for the objects. You can do the AWS Management Console, as well as if you have a case where you want to use bucket, like want to transfer a large amount of data, somewhere in a terabytes or something near to petabytes, Amazon also offers a service called Amazon Import Export, which helps you to upload huge amount of data to Amazon S3 or even to download that huge amount of data from S3. And we will explain about the import export on day 6. Now this is just a rough structure shown to you how it would look like. So when you see the structure, Amazon S3 will always have a bucket. An object cannot lie independently. So object would always be part of a sub bucket. Now one unique thing you always need to understand is this bucket name should be always unique across all Amazon accounts. Across all Amazon accounts means if I have a bucket name called Tarun Taste, you cannot create bucket name Tarun Taste within your account also. Any guess why this is the scenario? Why they have put this restriction? Bucket name is always part of a URL. These objects are always accessible over the URL. So that is the reason that bucket name is always part of this URL. So you cannot have a URL, common URL for the two different accounts. I'll show you the URL in the next slide so that will clear some doubts. So that's a restriction from Amazon. And again, you don't need to worry. If you create a bucket name which already exists somewhere, Amazon would warn you and would not allow to create that bucket. Now within that bucket, you will have a multiple objects inside. Now one different case for Amazon S3 is Amazon S3 with Amazon Management Console also allows the concept of a folder. A good point from Gaurav. I'm coming to same point now. So you cannot have a bucket inside a bucket, but inside a bucket you can have a folder. Folder is nothing like but a grouping of the multiple objects. So what would happen if you have a bucket and somehow this pen is, let me show you on the MS Paint if I can show that easily. So I hope you all can see my MS Paint. So what would happen? This is a bucket. Now within a bucket, if you have a multiple objects, object 1, object 2, object 3, object 4. Suppose this is the first one which we took here is a photo bucket. So if I just take example, this is my photo bucket. Now I have a photo for 2010, 2012. These are the different photos I have available. If I want to group the photos of 2010, 2012, how do I do it? For that, Amazon provides a concept called folder with Amazon Management Console only. So what folder will do? Inside a bucket, you can create multiple folders. And within that folder, inside that folder, you can have a buckets. Sorry, you can have objects. So this way, they would group the objects. Now, what do Amazon S3 or what Amazon S3 does is, it does not create a folder like a special as like a folder here. Instead, it just create an empty object. Folder is nothing but an empty object with a name as a /. What does I mean here? Suppose you have a folder called 2013. What it would do is, it would create an object with folder name 2030 or name 2013 and a /. Like this it will create here. Why this is helpful? If you see the now my PPT, in my PPT I've shown that Amazon S3 has a one bucket called my-images, another bucket is cloud.bucket.com. Now here the first object is friends.jpg, but second object is named as a 2011 /birthday.jpg. In this case, 2011 is nothing but a folder name. So folder name means it would be an empty object. It would be an empty object with just a / over there. So any objects whichever we put inside that folder would always have the folder name in front as a part of the URL. So this is just used for grouping purpose. So folder is used only for the grouping purpose inside a bucket. So this is the structure of a bucket, folder, and the object. Now, whenever you make an object or whenever you upload an object, it would be accessible by a public URL. Yes, you need to share that object over the internet for sure, but once you share that, always be a URL for that. And what would be the URL? URL can be of two types. One of them would be bucket name dot s3.amazonaws.com / object name. Again I repeat, bucket name dot s3.amazonaws.com / object name. Now s3.amazonaws.com, here S3 is shown because it's in US standard region. If it is in some other region like US West or something one, it will have S3 / West 1, S3 dash West 2, something would have that URL. So a bucket name dot, this is called virtual hosted style. Virtual hosted means you add your virtual host in front of your URL. So in front of s3.amazonaws, you add your virtual host. So this is the concept. Now there is another concept also, that is called a path style access. In that case, it will be the original URL will stay as it is, like s3.amazonaws.com /. In that case, it would come the bucket name / object name. So you can access object with any of the two URLs available to you, and each object would be available over the internet. So going S3 in detail, now I spoke about the S3 eventual consistency model. Now just a second. Eventual consistency model is a very important aspect. And what happens? Have you heard the word called CAP theorem? CAP. No one? Have you heard the name Dr. Werner Vogels? WERNER, Dr. Werner Vogels. Dr. Werner Vogels is CTO of Amazon, and he is the brain behind this huge success of Amazon itself, or Amazon Web Services. Now, just to share a news, I just read an article that Gartner's latest Magic Quadrant is out, and Amazon is leading by the miles in a public cloud. It almost captures 80% of the AWS market, public AWS market. That's what it was written there. I'm yet to see the that graph or whatever, that Magic Quadrant, but what that article was saying, it almost captures 80% of the success, and that's also success goes to the Dr. Werner Vogels. He's a really innovator. He's having a nice vision. Now, why I'm coming to this point is, CAP theorem talks about consistency, availability, and partition tolerance. As per that, you can, when you want to make a real scalable system, you can achieve any two out of this. That is, once you want the consistency, you can have either availability or partition tolerance. Partition tolerance means like a clustering kind of a concept. So if you want the consistency and partition tolerance, you may not have the high availability. If you want the consistency and availability, you may not be able to achieve the partition tolerance. Amazon goes with the concept of the availability and partition tolerance. The objects are not consistent. They follow a different consistency model called eventual consistency. In the eventual consistency, it would take a little while for the objects to become eventual. It means in Amazon, S3 there would be multiple clusters of the data, the storage. So once you upload an archive or any object over there, that object would be replicated on certain number of clusters before it becomes available to you and you can access that. Or before it becomes consistent. It's still available, but before it becomes consistent. Consistent means anytime you request, you would get the same object only. Now, since this is not the consistent, what would happen? If you once you upload a new object and you immediately try to read it, you may get the object or you may get an option called key does not exist because that object does not exist. Or suppose you immediately list keys within it, you try to list the key, it will say that it is not still fully propagated. You deleted an object and you try to read it. It may be still you can read it because it's not deleted from the all the clusters. It takes a while. Now this while means around a second only or a couple of seconds. But yeah, that's the time for you. That's why it's called the eventual consistency model. Your RDBMS are normally consistent. They follow the consistency model. And that is the reason they cannot achieve the clustering very effectively. Yeah, there are now the options available for all that. That's a different story. But for the RDBMS, normally they cannot achieve the clustering very effectively unless you go for Oracle with the rack and all that concepts. But you get that concept here is a clustering, so partition tolerance or consistency. So Amazon goes with the availability and consistent tolerance as part of the CAP theorem. Now, if you are planning for Amazon certificate exam, 90% you will get a question from this page. 90% chances you will get a question from this page. They normally ask a question about the Amazon consistency model. Which consistency model is followed in which region? So you'll say in US standard, it's an eventual consistency for all the requests. So whether you upload, you delete, you do whatever, it is an eventual consistency model only. But apart from US region, you go any other 7 regions, they will provide read after write. Read after write means it's a consistent read. You can read immediately after write. So for any new object request, they will provide read after write consistency in all other regions. But for put and delete, so over it, so for update and delete, they will follow the eventual consistency model. So US standard region follows eventual consistency everywhere. All other regions, for new upload, it follows the consistent read or read after write. But for update and delete, they follow the eventual consistency model. This is a point from where you can anticipate a question from Amazon. Now, S3 does not support the object locking. So if you upload an object and somebody also upload the object the same time with the same key, whoever is the last, they will win the race. So if you upload it at 10:31 a.m. and 55 seconds, somebody uploaded at 10:31 a.m. and 58 seconds, the 58 second would win the race and his object would be, you can see over there. So all the objects are key based. So we saw that everything is a key based concept only. If you upload a new object, it will delete the original object and upload a new object over there. Now in the S3, yeah, the difference between the eventual consistency and consistent read would be the eventual consistency gives you much lower latency and higher throughput. So that's also one of the reasons that this is a very helpful case. So it provides you much better throughput also. Now, this eventual consistency model, I would recommend everyone to read an article from Dr. Werner Vogels. Just Google on Dr. Werner Vogels eventual consistency model. He has written a very nice article that why this eventual consistency model is helpful in somewhere around 2008 or 9, I believe. And that is the background or base for so many NoSQL databases today. So that article was based for the so many NoSQL databases, because the NoSQL databases also, for most of the NoSQL databases follows eventual consistency models, and that's why they follow the availability, and generally they follow the availability and the partition tolerance. Some of them follow the consistency and partition tolerance also. So that's the concept of the eventual consistency model. I'll recommend everyone to read the article. His blog name is everything, allthingsdistributed.com. His blog name is allthingsdistributed.com. You should Google on all things distributed and eventual consistency model, or Dr. Werner Vogel's and eventual consistency model. You would read a very nice article over there. Coming back to S3, you can read and write object from 1 byte to 5 terabytes. You can completely read and write whole object. A bucket can be stored in one of the several regions, so 8 regions it supports, but the object would always be within that region only. It would be replicated internally within that region. It would never leave that region unless you specifically ask to do that. Amazon provides a little different authentication mechanism to ensure that data is kept secure from the unauthorized objects. Objects can be made private or public. Even you can given them the different rights also. We saw the access control list. The bucket policy will be seen in day 5. Amazon S3 supports the REST and SOAP based interfaces, but SOAP is now mostly deprecated, so it's supported only in HTTPS, and in future version SOAP might not be supported, so you should go with the REST only. Now whoever wonders what is REST and SOAP, it's a kind of a web service protocols. When you want to use the APIs or the SDKs or the web services, you have to use that. S3 also supports the BitTorrent protocol. When you want to upload a large object, you can use the BitTorrent to upload that also. S3 reduced redundancy storage, we talk about that. It provides you a lower durability with the lower cost. So that's the case, but it still provides you 99.9% durability also. It has all functionality same as S3 except the durability part. Now S3 bucket policy. So bucket policy provides centralized access to control the buckets. So we saw that, okay, we saw the access control list. You can give the bucket access in 2 ways, through bucket policy and through bucket access control list. Now with the bucket policy, as I said, it's a very powerful tool. You can give a much customized access, like to a particular bucket for a specific user, for a specific account. If you want to give only access during specific business hours, those kind of a scenario you can define with the policy. Access control list is a very coarse-grained requirement where you can give only view the permission, view the object kind of a permission only. It does not go much deeper level over there. Each bucket and object in Amazon S3 has an access control list. One more thing, whatever the bucket and object ACL are always independent. Whatever is implemented at bucket level does not transfer to the object, and whatever is at the object level does not come to the bucket. So we showed that during the demo also. Also, you can give up to 100 grants per ACL. So with the ACL access control list, you can give maximum 100 grants. After that, it's best to use the access policy, bucket policy only. Quickly on the S3 tools, there are various third-party tools also available in the market. Like you can use the application like Zamanda Backup. There is a Cloudberry, S3 Backup. You can use the S3 Sync or S3 Firefox Organizer. There are various tools available. You can use that also. Generally, the Amazon Management Console is the best. Second one, you can use the Cloudberry Explorer. This is a paid service, but it gives you much better control and options for you. Now in the APIs level, whoever is interested for the REST and SOAP, this is the slide for them. Amazon supports both REST and SOAP, but SOAP is mainly deprecated and supported only for HTTPS now. In future versions, SOAP may not be supported. Now these are the S3 APIs. So if you are working with the Amazon S3 SDK, so you are setting up your own program, you can use these are the different APIs. Now these APIs are also useful for the bucket policy. So we'll see in detail on day 5 where you can use these to set the policy also for the bucket or the user. Now coming to the almost end of the S3, a few simple S3 use case. S3 is useful for the media sharing. So when you want to share the media over the internet, so for some kind of a software distribution, like you have a software var file or distribution file, you can always store in a S3. So anytime you require, you can download from there. For your backup, so your on-premise backup, you can also use S3. People are using that for heavily. So all their on-premise backup like mail archive, all that kind of a concept, they can always store in S3. So that would be helpful for you as a storage purpose, as a backup purpose. It's very useful for the application storage also. A few popular things is one of them is a SmugMug. It's again photo website which uses it. Instagram used to use Amazon S3. Now, after they moved to the Facebook, I'm not sure whether they are using S3 or not. But initially they were using the S3 only. Dropbox is using S3. So these are the options for the S3 to use. So with this, we almost bring the end to the S3 session.